Hi everyone, and welcome to our video on finding the equation of a tangent or cotangent curve given the graph. So in this first one, I guess before we begin anything, let's just start with stating what each of them can look like. So our y equals tangent of x. So we often graphed it using the asymptote in the middle, like that. But we also said we could just find the other asymptote, which is the same distance as the other one, but to the left, and get our curve there too. Okay, so this is 1.5 periods of just the basic tangent function. Our basic cotangent function has the asymptote right at x equals 0, and then starts up high and goes to the other one downward. So we have these two. And so we want to know which one it looks like the most. This one, right away, number one, it matches the tangent form. Okay, so notice it goes through 0, 0, and then they don't put them there, but it looks like we can assume we've got an asymptote at 2 pi and at negative 2 pi. So we've got that there. Okay, and in both of these functions, in cotangent or tangent, from one asymptote to the other is the period. So I'm going to mark that right now. Okay, so we can find that period. It is just taking the higher power asymptote value minus the lower power. So we'll do that scratch work down here. So it's just 2 pi minus negative 2 pi. And that would simplify to be 4 pi. Okay, so I'm going to mark it here too. So we've got 4 pi. Okay, so I found the period right away. And then we did mention that it was tangent. So, and it's not shifted because it goes through 0, 0. So we know our curve is a tangent bx. All right, so we need to just find those pieces, and we've started it a little bit with our b. Let's continue in this grid to the rest of the work. Remember that the period for tangent or cotangent is based on pi over b. Okay, so we have the period is pi over b, and this problem tells us, oh, we have 4 pi. Let's change the period to be 4 pi. And then that way we can solve for b. So it looks like if we just cross multiply, or multiply the b over, we'll have 4 pi b equals pi. And then when we divide by 4 pi, we're going to have b is 1/4. Okay, so we've got b is 1/4. I'm going to cloud that. And then we need to find the a. So the a value is usually found by looking at the midway point between the intercept, the x-intercept, and the asymptote. So it should be based on the pi x value for this problem, and then we just go up to where we see it on our grid. Now careful, our scale is not 1, because if 2's up there, that means 1's right here. And so this is halfway between 0 and 1. So it looks like our a should be 1. Or not 1, 1/2. So I circled 1/2. I was looking at 1. So our a is 1/2 in this problem. And so then we can sub it in to here. So we have them both now. So we have our a, we have our b. And then we have it. So our final answer is y equals 1/2 tangent of 1/4 x. And there we go. Okay, and we can check, like if I plug 0 in, notice I will get 0 as a y coordinate. Let's plug in this value. So this should be negative pi and negative 1/2. So if I plug that in, so I'm just doing a quick check, y equals 1/2 tangent of 1/4 times negative pi. Well, that would be negative pi quarters. So we have y equals 1/2 tangent of negative pi quarters. Tangent of negative pi quarters is negative 1. And so, yeah, that matches this point. Good. Okay, so we could always double check. All right, so let's see this other one. So this one's shifted. Okay, so this was a tangent one. Based on our, again, just generic sketches, it looks like it's cotangent. Okay, so we could do tangent, it would be shifted differently, and there would also be a reflection. So cotangent's a little easier. Okay, so first thing, cotangent has an asymptote that usually starts at 0. This one, the asymptote got moved. Okay, so we instantly have the phase shift equaling to that 0.125. Okay, so instantly we have that. And finding these things, it doesn't really matter the order, but I do want to mark that right away. So I know it's a phase shift, and we said, oh, it's cotangent. So I'm going to put our equation here this time. So we know it should be A cotangent, and then because it's shifted, B x minus C. And like always, these letters can change. Often they use K for B, okay, so or lowercase a and maybe H for C. So they can change those letters, but it's the same form still. All right, so we have that, and it is tough to see those asymptotes. So let me resketch them. Those are dashed lines there. Those are the asymptotes. Okay, and then we want to find, okay, so we can go in any order. I'm going to break this down and say, well, this is where the period would be from there to there. And just like before, we're just taking the bigger x value. So on this one, it looks like 0.625 minus the smaller one, 0.125. And then we'll simplify, and that gives us 0.5, or a fraction, 1/2. Okay, so it's up to us. Usually I think they prefer fractions. Okay, so I'm gonna cloud that now too. Okay, so we have the phase shift, we have the period. Well, I clouded it, but really, what's more important about it is back to our equation, because we need B. Okay, so the period's nice, but we need B. So that's where we still use the same equation that we used from the last problem. We know the period is still pi over B. So we'll change the period on the left to be 1/2. And then we can cross multiply. So 1 times B is B, 2 times pi is 2 pi. There we go. That's what I really want. Okay, so we've got our B. Remember, the C is involved with the phase shift, so we have that too. And then the last thing we need is that A value. Well, same deal as what happened with the tangent. I just need to find the midway point between the asymptote and the x-intercept. Okay, so here's the midway point, and then it looks like it's up there is where it would hit the curve. And that length, okay, so that length is our A value. And it looks like the scale is 1 this time, so our A is 3. And it's not reflected, so that is +3 because it matches the same style as our most basic cotangent curve. Okay, so now we do have everything, and we'll just plug them in. So we've got y equals the A, which is 3, cotangent, bracket, 2 pi, parentheses, x. Our phase shift is positive 0.125, so that means keep it minus in here. And 0.125, I'm going to also just say, well, that is a fraction also. That is 1/8. And I'm doing that just because I can't really fit the 125 in. But I can fit that little fraction in. Okay, so there we are. So they usually like fractions anyway. Like that. Okay, so there we go. If you left it as a decimal, I mean, that's fine too. I just couldn't fit it. Okay, and then just like the last problem, we can double check. So if I plug in, let's see. So let's do the 0.5. So that point right there, 0.5 and -3. So if I plug in 0.5, so we have 3 cotangent, 2 pi, 0.5, I'm going to say is 1/2. So 1/2 minus 1/8. And then we could simplify this. Okay, so that would be 3/8. So, and if we need scratch work, that's for fractions, that's fine. I'm just running low on room, and I'm just checking anyways. And then the 2 pi or the 2 and the 8 would reduce. So we have 3 cotangent. That would be 3 pi over 4. And then cotangent of 3 pi over 4 is -1. Okay, yep, that matches. Good. Okay, and we could check the other points too, and we could check the asymptotes. Okay, so we could check all sorts of stuff. All right, but this is good. Okay, so that's how we find the equation. So tangent or cotangent, make sure remember the main thing with both of these. I'm going to put it right here. Remember the period for tangent or cotangent is pi over b. Okay, so sine and cosine, it's different. Tangent, cotangent, pi over b. Okay, so thanks for watching. If you do have any questions, please let me know.